Algebra 2, Section 2.5, graphing absolute value equations. Just do 3 examples. Here's the first one. Graph y equals the absolute value of 2x minus 1 by using a table of values. This would be the way that you first learned it, and kind of is always somewhat the go-to, right? You can always make a table of values, sometimes called a T-chart, right? So thing is you gotta figure out where the vertex of this graph is. You see, every graph that's of this nature, that has the independent variable inside of absolute value, no matter what else is in there, numbers and operations, whatever, they all have the same general shape. You know how like everything that's in slope-intercept form will generate a line, everything that's in standard form or point slope form too would generate a line. You may know that something that has x squared in it is called a quadratic, and that's going to give you a parabola. Certain families of functions have certain graphs that will go along with them every time. And this one is, this absolute value function, it'll always be a V shape. There'll always be two different directions, if you will. And you'll see that on all 3 examples that we do today, okay? So a good place to start is usually 0, right? So I plug 0 in here. I'm just gonna do the math mentally. 0 times 2 is 0, minus 1 would be -1. Then you take the absolute value of that, that would be 1. Plug in a 1, a 2, and a 3 and see what happens. I'm just going to do this quickly, but in real time. 2 minus 1 is 1. Take the absolute value of that, and that's 1. Now that's interesting. Plug in a 2. 4 minus 1 is 3. You're going to get a 3. Plug in a 3, you're going to get 5. Okay, and that's not going to change now, because do you notice that you keep getting positive numbers that are going bigger, and that's not going to change. You plug in a 4, you're going to get 7. You plug in a 5, you're going to get 9. I can put those on my chart, right? So now let's go into the negative. What about -1? -1 times 2 is -2, minus 1 would be -3, and then the absolute value of that would change this to +3, okay? So do you see that there's the same thing going on, kind of mirroring one to the other there, okay? And this will continue. You plug in -2, you're going to get 5. You plug in -3, you're going to get 7. So let's plot all these points now. -3, +7 is here, and then we're just going like this. There's 0, 1, 1, 1, 2, 3, 3, 5, and 4, 7. 5, 9 would be up here, so I'll just avoid that. This is going to be long enough. Now, again, they're shaped like a V. A lot of times when you do a table of values like this, you'll find the vertex. You'll find it, and it'll be kind of like this. In your Y column, it'll be kind of like this. You'll find out that the Y value is -2, and then you'll find out that this is 0, 0, and this is 2, 2, and they're surrounding that number. But in fact, in this case, the vertex is actually going to be right here where these 2 rays would meet. This is maybe not the best problem to start with, but it's actually a very good problem to cover. So I'm glad we're doing it. Gotta be blue. So draw yourself a graph that does basically the same thing I said about lines, is get it to span the graph as much as you can. Don't draw something really small. Don't draw something, this is a different scale, but these are your axes. Don't draw this, right? That's not big enough. Be accurate, make sure you have accurate points. Use the show with arrows that you know that it continues in that direction, right? So that's the graph of y equals the absolute value of 2x minus 1, okay, using a table of values. The second way that our book wants us to learn to do a graph like this would be by using the graphing calculator. So you have been introduced to the graphing calculator now, and you've actually even done an absolute value graph on the graphing calculator assignment, and now we're just going to kind of do that again. I already have that on my calculator. Just reminders about how to do this. You go y equals, and if you have anything else in here, you should clear that out. And I've typed in 2 times the absolute value of x minus 3 plus 7. If you've forgotten where absolute value is, it's under the math function. Press math, and then right arrow over to num here, and it's the first one, okay? And if I pushed enter right now, or if I push the number 1 right now, either way, it would overwrite the absolute value. Now I already have it in there, so I don't want to put that in. but this is what you should have. Again, if you have an older calculator, you might have 2, and it'll say A, B, S, parenthesis. Just put the x minus 3 in parenthesis, and then the plus 7 outside the parenthesis. It functions the same way. Okay. Now, another keystroke that I taught each cohort when we were doing the calculator assignment on the first day is Zoom 6. This is like a lot of times what I do instead of pushing graph. I was emphasizing the graph button a little bit more on that day because I want you to know where the graph button is. But a lot of times a good thing to do is to just hit Zoom 6. Just know that two key keystroke and hit Zoom 6 because it'll take you right to the standard window. The standard window pairs nicely with the graph paper that I use, which is on the same window if you go by ones. And this is what you see. Now, I'm not crazy about that as it turns out, so I am going to go to the window and adjust so that I can see more of it by adjusting my Y max. Let's go up to 25, and we'll go on the Y scale by 2s instead of 1s. That looks a lot better, right? Now, to use your graphing calculator is not to just look at this and mimic the window. You don't want to now start transferring points over. No, we still want to be specific, and I'm going to show you a new feature on your calculator that is the table. This is an electronic T-chart right here. We just used a table of values or a T-chart on the first example. This is as many points as you ever could want. Okay. Now look at where the vertex is. It's at 3, 7, right? As I look down here, 17, 15, 13, 11, 9, 7, and then back up, 9, 11, 13, 15, 17. So right here is the vertex 3, 7. And I'll tell you something, it's not a coincidence that you see a 3 here and a 7 here, but we'll talk about that in the next lesson, okay? So I'm not going to actually graph this one because you could do that yourself. You type it into your Y equals, you go to the table, which is second graph on your calculator. You push the second key in the graph key, that's the table, and then you can pick off good points there, use it just like a T-chart, okay? Now, there's one more way that the book would teach you how to do this, and I'm not going to teach this way. I think two methods is enough. Probably don't need 3. So we're just going to do this one the same way we did the first one. And you know what? If you wanted to do this with me and kind of get some practice, watch me do it by hand while you practice another one on the calculator. That's perfectly fine, okay? So again, I'm going to start at 0, not knowing any better. 0 plus 6 is 6, minus 2 would be 4. And then I go 1, which is going to be 9 minus 2 will be 7. And I'll do one more, 2, which is 12, minus 2 would be 10. Go negative 1, that's going to be negative 3. Plus 6 is 3, minus 2 would be 1. Plug in a negative 2, which is going to give me 0. The absolute value of 0 is 0, and minus 2 would be negative 2. Plug in a negative 3. I'm starting to write small because I'm running out of room. But here's where the absolute value is going to have to actually work, okay? Negative 3 times 3 is negative 9, plus 6 would be negative 3. The absolute value would be 3. That's the first time that the absolute value changed negative to positive. So that's 3 minus 2, which is 1. And you see this? That means that this is the vertex, okay? And now I really don't need to do the math. Do it if you want to, but if you plug in a negative 4, you're going to get a 4 because these are going to be the same. So we found the vertex. It's at negative 2, and then I'm just plotting all the rest of the points. There's all the points that I have. You can project it out a little bit more. You can see that kind of in a slope kind of way, because really what an absolute value graph is just the conjunction of 2 lines, or really 2 rays, if you remember that word from geometry, 2 rays. So this is like up 3, left 1, up 3, left 1. Just keep going. And then graph it. Connect them. Long lines. Use a straight edge. You don't have this feature that I have, but you can use a straight edge and produce a nice, accurate graph that passes through your points, spans the graph, and you can identify some intercepts there as well. All right, thanks for watching.